Hello everyone. Now we'll discuss about a pumped storage plant. Everybody knows there are different types of plants constructed on the rivers. There are low head dams, high head dams, and medium head dams uh, according to the availability of the head, the catchment area. And you can see there is a cascaded dams are also there. That means the output water of a dam acts as the input water to the dam below that dam. So these cascaded dams are also there. So in order to not waste the water which is released, so that was one of the technique. So if you observe the dam, once you release the water, normally in the dams or the reservoirs, you cannot take that water back. So you may be releasing the water for irrigation purpose or drinking purpose or for generating the power. So if we are able to reuse that water which we have released, so that will be a good thing. We can generate whenever we want. So on that concept, cascaded dams were built. For cascaded dams, there should be proper availability of that site, physical ground conditions to construct these cascade types of dams, where it is very rare. We can see such type of things very rare. That means continuously there should be availability of that areas to construct that dams. So if I construct one dam, below that dam, again there should be one catchment area. There should be a proper conditions to construct another dam there, and after the dam, below the dam, again there should be another conditions availability of that area to construct the dam. So, but here the main advantage there is we can use that discharged water from the dam which is at the top, that is used for the input of the dam which is below that dam. And again, if you discharge the water from the dam, again there will be another dam, but that type of availability is very rare. The type of conditions, physical conditions on the surface of the earth is very rare. So today we will see similar to the type of dam. So where there is no need for so many catchments like cascaded dams. So this is a pumped storage dam. So there is advantage if you are able to reuse that water which we have discharged. So the pumped storage dam. So it is the dam where we can discharge. We are going to discharge the water whenever there is a necessity for the generation of more power. And this water which comes out of this dam or power plant is stored again in a reservoir below that dam, and we will again pump that water which is discharged and which is stored in the reservoir below that dam, and we will pump them back to the dam, and we will store, and we will reuse whenever it is needed for us. So whenever it is needed for us means, that means here in the load conditions, in the demand. So there are different types of loads: peak load, medium load, intermittent load, and low loads. So during the peak load times, if there is a power plant, it is unable to meet that load, the peak load. So we have to meet that peak load. So during that times, we'll release the water in this dam or plant, and we will generate the extra power which is needed to meet that peak load or demand. After the peak load, after that time is over, during the less demand times, we will again use the motors and will pump that water back to the dam during the low peak times. So this is one of the good concepts which we can meet the higher demands. So there are mainly two types of operations going here. First phase is pumping phase. So this is the phase, that means during the less demand periods. So okay, we are having less demand, so we can no need to supply all the power which is generated to the load. So some excess of power we can generate now. So that power we will use for this pumped storage plant for pumping the water which was released during the peak times, during the high demand times, for generating the power, and we will store this water in that dam. This is the first phase. So in this phase, the motors will be, the pumps and motors will be in the operating mode. And there is second phase, that is generating phase. In this phase, we are going to release the water which is stored in the dam during the less peak times, less demand times, and because of the head, because of the penstock, and the water is reaching to the turbines in this pump storage plants, and the turbine is going to rotate. So the turbine is in the operating mode, and this turbine is attached to the, coupled to the generator, and we are going to generate. The generator is going to generate the power. So that's why we are calling this as the generating phase. So the main thing, the main application of this pumped storage dam is that we can use this for meeting the demand at peak demand periods. Okay, and during the low electricity demand time, the water is going back, and during the high demand time, the water is coming out of this dam or the reservoir. Okay, so that means there is a, simply we can say that this consists of high level reservoir and a lower level reservoir. So during the less demand times, we will pump the water which is stored in the low level reservoir to the high level reservoir, and during the peak demand times, we will release the water from the high level reservoir to generate the electricity which is needed to meet the demand. Okay, the main things, the main parts in this pumped storage plant dam are the upper reservoir and the intake tunnel and the turbines and the discharge tunnel and the discharge channel. Okay. So here we are recharging the water back and releasing. So we will be having a controlling mechanism to generate the power. So the advantages here in this pumped storage dam. First thing is there is no pollution. It is renewable. We are using it how many times we want, and we can generate the power within few minutes. So there is no delay. There is no lag of meeting the demand, and this is reliable. So there is the water which is discharged is stored in the low reservoir. So whenever we want, we can pump it back, and we can generate whenever we want. So when you come to the disadvantages, the disadvantage is we cannot find the convenient landscape areas for constructing these type of dams. And if you are using, another disadvantage, if you are releasing the water, and we cannot generate the electricity until we pump it back, and the landscape is also very little. That means the storage of water is little and it is expensive. So there are different places where we can find this type of pumped storage dams or pumped storage power plants. So in India, in Bihar and in Maharashtra, we are having a 150 megawatt capacity of pumped storage dams. In Purulia, pumped storage project, Ayodhya Hills. In West Bengal, we are having the capacity of 900 megawatts. In Tehri, the Tehri Dam, which is in Uttaranchal, so it is under the construction. Its capacity is 1000 megawatt. So this is all about the pumped storage dam, which is useful for meeting the peak loads, peak demands. This is the use of this pumped storage dam. Thank you for listening.
Like, share and subscribe. Hit the bell icon for more updates.